All right, so let's go ahead and solve few basic trig equations. So here's our first example. We want to find all the solution to the example cosine theta is 1/2. Well, you pretty much want to know what is theta so that cosine is 1/2. So we know from our graph of cosine function, cosine theta will give us 1/2 if theta is equal to pi over 3 or 60 degrees. So you can think of it that way. So we know cosine of 60 is 1/2, but that's just one period, one interval. But we want all of them. So if you want all of them, you would say theta has to be equal pi over 3 plus 2 and pi, where n will run from all integers. So if n equals 1, you have the period of the second cycle, and so on. Now, that's one, but there's another place where cosine also gives you 1/2. So if we draw the angle in our unit circle, so let's say here's the unit circle. So we have an angle right here, which was pi over 3. So that gave us cosine of 1/2. But we know cosine is also positive in the fourth quadrant. So we also want this angle right here. So we can draw that angle. So we want this angle right here because that will also give us 1/2 for cosine. So to find that angle, we're going to do 2 pi minus pi over 3, and that would give us 5 pi over 3. So for 5 pi over 3 of cosine, you also get 1/2. So therefore, our theta is also 5 pi over 3 plus its period multiple of n. So that would be 2n pi. So those are the angle when our cosine value is going to be positive 1/2. All right, so now let's take a look at another example. So here's another example. We want to find theta when this equation is equal to 0. So we're going to do some algebraic work. So what I would like to do is introduce a variable so that we can replace sine theta. So we can just say let x be equal to sine theta. So that means everywhere you see sine theta, you're going to replace it with x, so it becomes an algebraic equation. So our equation now becomes 2x squared plus 5x minus 12 equals to 0. And then you try to solve this algebraically. So we have, we're going to factor this. Looks like it is factorable. So we have 2x here and x here. And we want to see what are the numbers for these factor. So I can do plus 4 here and minus 3 and see if that works. So we have negative 3 times 4, that's negative 12. And the middle term will be positive 5x. Okay, so that looks good. So now we set each of them equal to 0. So we have 2x minus 3 equals to 0. And we have x plus 4 equals to 0. Well, now we can sub in what is x. Well, we said x is equal to sine theta. So let's sub this in. So we have 2 sine theta minus 3 equals to 0. And then we have sine theta plus 4 is equal to 0. And then you just solve each independently. So for the first one, we can add 3 and then divide by 2. So we have sine theta is equal to 3 over 2. And then for the second one, we have negative 4. So we have sine theta is equal to negative 4. All right, so these are the two exact values we have. Now let's ask ourselves, was sine in the unit circle? So if you look at the unit circle or the graph of sine, we have, so this point is 0, 1, and then this point is going to be 0, negative 1. So sine does not have range greater than 1 or less than -1. So sine of 3 over 2, this is approximately 1.5 or so on. Now that is greater than 1. So that means there is no theta value that will correspond to that. So this equation has no solution. Now what about the second one? Can sine theta be -4? Well, again, it cannot be lower than -1. So again, this one has no solution for theta. So therefore, we say that our equation actually just has no solution. So something like that can arrive when you're solving these equations. All right, so let's take a look at another example. So here's our next example. Now for this one, we want to find 4 cosine squared theta minus 3 to be 0. So again, your goal is to isolate the trig expression. So we want to isolate cosine theta. So first thing I want to do is add 3 to both sides. So that would give us 4 cosine squared theta is equal to 3. And then we can divide both sides by 4. So let's go ahead and do that. So that would give us cosine squared theta is equal to 3 over 4. And finally, we're going to take the square root on both sides to get rid of the square, but we have to remember to bring in plus and minus. So hence we have the equation now, cosine theta is equal to plus and minus radical 3 over 2, if I take the square roots on the right-hand side. All right, so now what that means is we want to find, so what this means is we want to find cosine theta that will be positive radical 3 over 2, and we want to find cosine theta to be negative square root of 3 over 2. And we also want to make sure that our answer lies between 0 to 2 pi. So only on that interval. So we don't have to add in that period multiple of n. So that takes care of that. So now let's go ahead and solve the first one. So we want to find when is this true. So if we draw our unit circle or just the xy plane, we know on the unit circle cosine of, on the first quadrant, some angle will give us radical 3 over 2. Well, that's going to be pi over 6. So this will give us, so cosine of pi over 6 will give us positive radical 3 over 2. So we found one of the answer for the first equation. So let's just list them right here. So our answer is going to be pi over 6. That's for the first positive square root of 3 over 2. Now cosine is also positive on the fourth quadrant. So now we want to find this angle, because that will give us the fourth quadrant where cosine is also positive radical 3 over 2. So this angle is going to be 2 pi minus pi over 6, and that would give us 11 pi over 6. So cosine of 11 pi over 6 is also radical 3 over 2, so this is 11 pi over 6. So we found the two positive ones. Now let's find the negative ones. Well, the negative one has to be in the second quadrant and the third quadrant. So let's go ahead and do those. So we're going to go ahead and find this angle, because that will give us the negative radical 3 over 2. So that angle is going to be, so let's do it right here. It's going to be pi minus pi over 6. Again, we're using the same reference angle for all of these. So that would give us 5 pi over 6. So our next solution is 5 pi over 6. So cosine of that is going to be the negative square root of 3 over 2. And the last angle we're looking for is on the third quadrant. So we want to go all the way around and end right here. And that angle can be found by pi plus pi over 6, which will give us, oh, running out of space, that'll be 7 pi over 6. So the last solution we have is 7 pi over 6. So there you go. So these are all the theta values for this example, and this is within the period of 0 to 2 pi. So these thetas are between 0 and 2 pi. All right, so that's it. I hope this makes sense.